Okay, so using example 4 as a little recap, and it's also going to be a little segue to take us into what we're going to talk about today. Here is what we're going to divide, and we're going to be reviewing synthetic division. You might need to refer to your notes because I'm going to ask you for some things. And if you don't remember, you can look at your notes. Yes, it is posted, yes. You'll catch up, you'll pick up on a few things today with the synthetic. What you'll really need to catch up on is the long division because I won't talk about that today. Okay, so let's review our synthetic. We begin with the large kind of upside down division sign like so. And remember, we are looking for coefficients. So when I say x cubed, what do you say? 3. Thank you for that. I say x squared. What do you say? Correct, a 0. And then x, -5, and then the constant 10. Very good. So that was one of the things to remember, that you need a column for every power. And then I asked you this question, is x minus 1 a binomial? Yes, it is. So what do I put over here? You change the sign, so you put 1. And go ahead and draw your arrow and bring down the 3. That's your starting point for the synthetic. Make sure you draw the arrow, because if you don't put it there, you're going to accidentally put a number in that spot, and it's going to mess up the whole thing. Okay, does anybody remember the operations that we did? Multiply and then add. Very good. That's the flow. Multiply, add, multiply, add, multiply, add. So let's begin. I say multiply, you say what number? 3. Thank you. We're going to put that right here under the 0. I say add, and you say 3, because 0 plus 3 is 3. All right, multiply. 3 again. And then add. -2. Good. Multiply. -2. And then add. 8. So that was the flow. Multiply them, add down, multiply, add down. Does anybody remember how the answer begins? How? Yes. 1 less than that. Down 1 power. So the first coefficient is 3, and it is on x what? Squared. Very good. And then I continue to go down from there. So I write plus 3x, and then -2 is the constant. And what is 8? The remainder. Very good. So plus 8 over, what do I write it over? X minus 1. Very good, which is the divisor. Very good. Okay, I'm going to use this example to have a little segue into one of the things we're going to do today. I would like for you to think of it like this. What if I called this polynomial, so same thing, just kind of piggybacking on this. What if I called it f of x, and I asked you to find f at 1? What does it mean if it asks for that, f at 1? Plug it in for x, all of the x's, right? So f at 1 is to say 3 times 1 cubed minus 5 times 1 plus the 10. No, it's just kind of a continuation. It's going to prove a point here in just a second. And then let's finish it out. When you cube or square or whatever a 1, what do you get? 1. So let's go ahead to multiplying. Multiply with the 3, and you get 3 minus 5, thank you, plus 10. Finish it. What is 3 minus 5? -2 plus 10, 8. Okay, now I know that seemed really random, but this is going somewhere. Do you see an 8 anywhere in our synthetic division? It's the remainder. You have just proven what is called the remainder theorem. The remainder theorem says that to find a function value f at that number, you can use synthetic division, and the answer is the remainder. We'll write this down in just a second, but I want to point something out. Do you remember what question I asked you about x minus 1 as it pertains to setting up? you remember what I asked you? Is this a what? A binomial. So because it was a binomial, what did we do? We changed the sign. So follow-up question. Is f at 1 a binomial? I need your attention here. I've got a lot of wandering eyes and glazed over eyes. I know we're tired after lunch. I get it. Is f at 1 a binomial? No, there's no plus or minus in there. That's what makes it a binomial, the minus sign. There's no plus or minus in f at 1. It's not a binomial. So if it's not a binomial, what happens? It stays. You keep it the same. So if you have a binomial, you have to flip the sign. If it is not a binomial, so here's an example of not, you have to keep it the same. Do you see how that all worked out? It was intentional that I asked you for f at 1 and not f at negative 1. That would have been a completely different answer. Okay, so now let me give you a little kind of ending to this. That was the point of that, is to show that the function value is equal to the remainder. So now we're going to go into this little bit of notes that I'm going to give you called uses for synthetic division. And I'm going to subtitle it and how to answer. There are 3 uses for this. And you've done all 3. We're just kind of putting them all together now. The first use is just dividing. Just divide the polynomial, just like example 4. Divide this polynomial by this binomial, and that's it. The answer to a problem like this is the full polynomial answer. That is starting down 1 power, and then you continue on with your coefficients, and that's how you answer. So that was like example 4. The second one is called the remainder theorem. I'm going to go ahead and introduce that title. The remainder theorem is finding f at, and I'm putting a in there because a is representing some number. You're finding a function value, f at something. When you do synthetic division on this to find that answer, the answer is the remainder, whatever it is. No matter what the number is, that's the answer. Like on the last example, the answer was 8. That was it. So that's what we just demonstrated. And the third application is something we had done on Tuesday, and that is determining, is the divisor a factor or not? So I'm going to ask you to remember from Tuesday. Do you remember what you're looking for? Remainder 0, right? So the answer is a yes or no. That's the answer. So if I'm telling you how to answer, that's what I'm doing. But I'll take this opportunity to remind you that to get a yes, you have to have a remainder 0. And I'm not putting anything on the no, because if it's not 0, it's a no. Anything else is a no. Okay. So we're going to practice some of these and show the kind of the applications of it, especially that factoring one. There's like a little bit further we're going to go with that factoring one, the yes or no, because there's an additional question they could ask you on that. So I'm going to show you what that looks like. So are we ready? All right. So we're on 5, right? Then we just did 4. Here we go. got some a little bit high numbers here. That's okay. Sorry, find the following. So for part A, we're going to find, we'll keep it kind of simple. We'll find f at -1. I'm going to put an equal sign there, and that's where our answer is going to go, but we're going to put our work down below. So now we're doing this problem going kind of straight to the bottom line, not having to do, like we're not doing the comparison. I'm not doing it two ways. I'm doing it one way, and it's the way I think is easier. So setting up the synthetic division, I say x cubed, excuse me, you say what? 1, thank you. X squared, 10, thank you. X, 29, and constant, 24. Very good. Bring down the 1. And then we didn't really take notes on this, so let me just kind of do this again with you out loud. That f at -1, is this a binomial? No. So what number goes on the outside? -1. Okay, so the little note on this is that it is not a binomial. That's what matters. It's either a binomial or it isn't. Okay, let's carry out the synthetic. I say multiply. What do you say? -1, thank you. So -1 is going right there. Go ahead and add 9. Good. Multiply -9 and add 20. Good. Multiply -20 and add 4. Those weren't too bad. They could have been worse with those 20 and 24 numbers, 29, 24. Okay, now what is the answer to f at -1? No x's. Go back over here. Go back over here. What do we put as the answer for a function value? 4. Why is it 4? The remainder. Very good. That's how you answer. So f at -1 is equal to 4. That is it. Okay, let's do another one. We're going to do the same polynomial, but let's up it to -2 this time. It is the same coefficients, so I'm going to go ahead and borrow that work that we've done with the 1, 10, 29, and 24, and bringing down the 1, zipping through that part a little bit quicker. And then let's review this part that's new today. Is f at -2 a binomial? No. So what do I put on the outside? -2. We do not switch the sign. Okay, ready? Multiply. Thank you. Add. Multiply. Add. 13. Good. Multiply. -26. And add. -2. And the answer to f at -2 is -2. Excellent. Have we caught on yet? These are not difficult. You just have to know how to answer and what you're doing here. Okay, let's go on to one of our other applications, which is talking about it. We were revisiting it. We had done a little bit of it on Tuesday, but we're revisiting the idea of the factor. Okay. So we'll call this part A. We're going to start with this question, and then depending on the outcome, we're going to extend the question into something a little new today. because we answered this on Tuesday with just a yes or no, but there is a little extension beyond this, and it is very intentional. I've never seen it asked in the textbook, but I don't hate it. It's a good preparation for the next step in the process, because you actually are laying a foundation of something a little bit more complicated. You're about to solve polynomials that are not quadratics, and you're doing it with synthetic division. Anyway, that's a future problem. In fact, that'll be after the break, because we're only going up to 3-4. But in January, we'll be talking about what this foundation is that we laid. So anyway, future problem. All right. If it asks about something being a factor, what should I use? Say the method out loud. That's what we've been doing. Synthetic division, yes. So you should be using synthetic. And remember, Monday we talked about why we are allowed to use synthetic. It has to do with the x minus 6 being kind of basic, just x and a number, nothing fancy. Let's set up the synthetic, and then we'll talk about what kind of answer we're giving. I say x to the 4th. What do you say? 1, thank you. X cubed, -8. X squared, 16. X, -23. And constant, -6. Very good. Go ahead and bring down the 1. Now, is x minus 6 a binomial? Yes, it is. So what do I write? Correct. Okay, so we're seeing the two different applications here. When do you switch, when do you not? Here we go. Ready? Multiply. 6. Add. Good. Multiply. Add. Multiply. Add. 1. Multiply. Add. Maybe that's a reminder of how we answer this question. Is x minus 6 a factor of the polynomial? Why do you say yes? Because there is no remainder. Okay, so to answer this question, because of that 0 right there, yes. That is the answer to the question. Yes, x minus 6 is a factor. But now here is the extension beyond that. Right? What do they call this? If it is a factor, which is, write the polynomial, okay? So write the polynomial as an expression of 2 factors. So this is the part I need to teach you new. Here's what has happened, and I am going to recopy the polynomial. It's a little tedious just because the polynomial is kind of long, but stick with me here. I'm just copying down the initial polynomial. Okay, so we're going to start with that. And I'm bringing it down here to show the kind of the starting point, if you will. And here's what it means by writing as expression of 2 factors. It's like this. Because you have figured out that x minus 6 is a factor, it's synonymous to taking out what is common, right? Like if you could have taken out a 2, something like that, you'd write the 2 on the outside, and then you'd write what's left. How do you get the what's left if you're just taking out a 2? What are you really doing when you're taking out a 2? You're dividing out, right? So you divide out the 2 and you write what's left, yes? Well, think about it. If you are taking out the x minus 6, where do you think the rest of it comes from? It's on the board somewhere. Take a wild guess. Where? The synthetic division. What part? Yes. What part? The answer. That's it. You're dividing out the binomial x minus 6, and when you divide it out, that's what you're left with. So we're going to write that polynomial as the second factor. See this product of 2 factors, or an expression of 2 factors? That's the second factor. So what does that term start as? 1x to the 3rd cubed, because we're going down 1 power. Very good. So then what's the second term? Minus 2x squared. Continue. Plus 4x. And then plus 1. Will there be a remainder on that? No. Why not? Because it's a factor, right? That's the only time you're going to be doing this whole thing is if it's a factor. So you're not going to be writing, this expression of two factors if the initial one that you found out isn't a factor. That would be a moot point. Okay? So that's the follow-up to this. It's going to say that. It's going to be in your homework. It might be on the quiz test, all that stuff, to write the expression as a product of two factors or something like that. Okay, so let's do it again. That was kind of the original binomial, asking if that was a factor of that. We found that it is. Yes, it is. So then that's the factor. Right. All right, so let's do it again. And it's the same kind of question here. But we got new expressions. My plan is to do B and then C, and then we'll be done. I think we'll be good at that point. Okay. So if you're asked a question like this, what method do we use? What is the synthetic division? Thank you. The process is called synthetic division. All right. So let's go with our coefficients, starting all the way up at x to the fifth. What number do I write? 1. X to the fourth? Good. Cubed? -5. Squared? X? -1. Constant? 3. All the way down to the constant. Go ahead and bring down the 1. Now I'm going to flip this question around to you. What do I care about x plus 3? It's a binomial. Thank you. Because it's a binomial, what do I write on the outside? -3. Good. And let's begin and see what happens. Multiply. -3. Add. Good. Multiply. 9. Add. Good. Multiply. Add. Multiply. Add. Multiply. And what is the only thing I care about? It's not 0. So sometimes I like to do something like that just to kind of show that doesn't really matter what it is. It's not 0. So that's the end of the problem. So is x plus 3 a factor? No, it is not. And that's the end of the problem. Like I wanted to show this one to show that you can't express it as two factors when it's not a factor. So that question would have that would be a dead end. So we're going to do C, and I want you to try this one on your own, and then I think we'll be done. I think we'll be good. All right. So is the binomial a factor? And if so, write as two factors. Okay, so just giving you the instructions there. And now for the terms. The binomial is this. And here is the polynomial. And then once you get it, you can go ahead and begin, and I'll meet you at the end. How do we do? Getting it? Okay. We love synthetic division. It is as easy as it seems, but I'll tell you how people mess this up. And the answer to that is found on this slide right here, knowing how to answer. And I just tell you what has happened in past quizzes and tests, because you're taking different quizzes and tests than what they are past years. But let me show you what has happened. You have a question, right? And you're asked to find f at 3, and the blank is this big. And you do synthetic division, and an answer to synthetic division is very long, yes? But do you see how short that blank is? How do people mess that up? Because they come to me and say, am I really supposed to fit this in that blank? How are they messing it up? And then I'm not telling them. I say to them, you have to know what the answer is, or you have to know what to do. I can't help you. What have they messed up? The answer is the remainder. That's it. They're trying to give the full polynomial for the answer when really it's just the remainder. So they're doing the synthetic, and that's great, but knowing how to answer. So that's why I say this right here is your lifeline of knowing how to answer the questions. Okay? It's not a difficult thing, synthetic, but you have to know the uses for it. Do I answer yes or no? Do I answer with the remainder? Do I answer the polynomial? What am I doing? What am I answering? Okay, this is me trying to spell it out for you and trying to help you with that. Any questions? Okay, that's the end of 3-4. That's it.